frequency tables and histograms, organizing and visualizing quantitative data. When you have raw data, you need a way to organize it into a useful summary. Here are our 10 data values from the stemplot example. A frequency table groups these values into class intervals and counts how many fall in each one. It also calculates relative frequencies, which are proportions or percentages, and cumulative frequencies. Here is our frequency table with uniform class intervals of width 10. The columns show the class interval, the frequency or count, the relative frequency as a percentage, and the cumulative frequency. The 0 to 9 class has one value, which is 10%. The 20 to 29 class has 4 values, making up 40%. By the time we reach the 20 to 29 class, 60% of our data is accounted for. The 50 to 59 class has 2 values, bringing us to 100%. Note the endpoint convention. The class 0 to 9 includes 0, but excludes 10. Aim for 4 to 12 class intervals, and they can be uniform or non-uniform. A histogram is the graphical representation of a frequency table for quantitative data. We set up axes with class intervals on the horizontal axis and frequency on the vertical axis. Notice the key feature of histograms: the bars touch each other. This is because the data is continuous, and each bar represents a range of values with no gaps. The height of each bar shows how many observations fall in that interval. The tallest bar is the 20 to 29 class, with 4 observations. A common confusion is the difference between histograms and bar charts. Histograms are for quantitative, continuous data. The bars must touch because the horizontal axis represents a continuous scale with no gaps between intervals. Bar charts, on the other hand, are for categorical data. The bars do not touch because each bar represents a distinct, separate category with no natural ordering or continuity. Bar charts can also be used for frequency tables with non-uniform class intervals. Let's formally define the 3 types of frequency. Frequency is simply the count of observations in each class interval. How many data points fall in that range? Relative frequency is the proportion or percentage of the total observations. Divide the count by n to get it. Cumulative frequency is the running total of relative frequencies. It tells you what percentage of the data falls at or below a given class. For example, a cumulative frequency of 60% at class 20 to 29 means 60% of your data is 29 or less. Let's recap. Frequency tables organize data into class intervals, tracking count, proportion, and cumulative proportion. Histograms use touching bars for continuous data. Bar charts use separate bars for categorical data, and always aim for 4 to 12 class intervals with a consistent endpoint convention.